Surrounded by tropical forest outside Havana, the Tropicana nightclub has been a place for Cuban and international social elites to watch extravagant shows, eat, and drink since the 1940s. A series of colorful cylindrical shells welcome visitors to the nightclub and provide a grand entrance as they walk up under the lighted shells next to a wall of mirrors. The establishment of the Tropicana began in the late 1930s when entrepreneur Victor D. Correa was inspired to create a high-class nightclub on this attractive property. In 1940, it opened and was named the Tropicana. Quickly, the open-air nightclub began drawing in well-known performers and socialites. Under new management of Martin Fox in 1949, the first indoor section of the nightclub was commissioned to accommodate the crowds on days with bad weather. Fox had previously worked with Max Borges, a modernist Cuban architect, and commissioned him to build a covering for the large hall area while retaining and highlighting the surrounding foliage. The resulting Arcos de Cristal is regarded as one of the most compelling pieces of Cuban architecture by Cuban architectural expert Eduardo Rodriguez. It is possible that Max Borges also designed these outdoor shells, although their true architect and engineer are unknown because their date of construction is undocumented. In a similar way as the Arcos de Cristal, these colorful shells highlight and enhance the surrounding foliage and do not disturb it. The concrete for these shells was poured around the tree trunks to allow the trees to stay in place and appear to be bursting through the vaults.
This entrance awning is comprised of a series of single curvature shell barrel vaults. Each one takes compressive forces from gravity loads and transmits them down in a lateral direction to the pillars placed at the intersection of each arch. The vaults behave as either arches or beams or a combination of both, depending on their length. Longer shells, such as this blue shell, act as beams, while shorter shells, such as the green shell, act as arches in the longitudinal direction, spanning from the curve of the driveway back to the mirrored wall. The efficient barrel shape of the vaults reduces stress in the transverse direction and therefore allows for elegant thin shells. Additionally, there are tension ties that span from crest to crest of the barrels to prevent relative motion between the shells that can be caused by wind forces acting on the trees encircled by the shells. The holes in the shells disrupt the flow of vertical forces because there is not a good bond between the tree and the material around it. Thus, the tree acts as a hole. Fortunately, barrel vaults maintain their stiffness so long as nothing interrupts the longitudinal crest of the vault, so the shell remains effective. Tension ties attach the shell to the adjacent building and poles. These were likely an original member of the structure used to support the shells in the horizontal direction.
These shells were built similar to other typical concrete shells. The concrete shells are likely connected using a rigid beam, such as a drop valley beam, and constructed using moving forms. It is likely that 2 or 3 different forms were used during construction. The different shells also appear to be either translations or mirror images of each other. During the construction process, the movable formworks were probably used to recreate many different shells of the same dimensions but in slightly different orientations and locations. The wall behind the shells was most likely constructed first with steel rebar sticking out of the top. The concrete for the shells was then poured over the formwork for one of the shells on top of the wall. After the first vault was completed, the formwork was removed and moved to the next location where the shell construction process was then repeated.